So, troubleshooting. How to troubleshoot. One of the things I've noticed on the Facebook groups is that people ask questions but they don't know how to process the answers. And there's an awful lot of people on there who are trying to be helpful, but they're sending them off in all the wrong directions because they haven't got the ability to think in the required manner. And it's not because they're stupid or anything silly like that, it's just because they haven't actually thought about it. This is the way I do it, and this is the way my colleagues did it. I've been in this business since 1974. That's well over 40 years ago. And when I was trained, I was taught by a very good trainer in college. And he said, try and keep things simple. Don't make life more difficult for you than you need to be, and go with it this way. And he showed us how to do it. You've only got to look at the groups to see that people ask a question and somebody comes up with, oh, it could be this, and somebody says, oh, it could be that. And I've seen the guys, me included, who have been trying to answer the questions, and we get shouted down by people who are saying, oh no, it's this, go and do this, No, that's like telling you to pour petrol on a fire when you want to put it out. Very often it's the wrong answer, or it's going to lead to the wrong answer if it isn't actually the wrong answer. There's a few guys in the group who are very good, and they really do try. They're worth listening to. These are the tips that we were given, and this is what I'm going to try and pass on to you. Now here is what pros do. This is quite relevant, I think. This is a system or a block diagram. Can you see the deliberate mistake? I'll say deliberate mistake. It wasn't a deliberate mistake. I made a mistake when I did the drawing, but having now put it up, can you see the deliberate mistake? This is how engineers look at systems. This is how engineers look at service manuals. Service manuals have these in them, but we think of them this way. Somebody says, oh, it's the colour demodulator. It doesn't matter whether it's got 5 transistors in it or 100 transistors in it. If the demodulator is not working, it's not working. Then you worry about how many transistors it's got in it. But you find the fault first, you find the area of the fault, and then you trace it down. If you watch the videos on YouTube from people like Big Clive, TechMoan has had a go, and Technology Connections is very good. You'll see that they do a little bit of troubleshooting. It really is, when you see them doing it properly, it's magical. You can see this, the thinking, and they start talking in systems. Oh, the tape's not loading properly, therefore it must be something along these lines. There are certain people on YouTube that are not particularly worth watching, but the ones who know what they're doing, it's magic. And you see them do it, and you can see it's the system. Work out what it does, work out how it does it, then see why it doesn't. That's all you got to do. Now this is a real case study. It really is a real case study. It did happen. 1983, something like that. A long time ago now. But I had one of these in, and this is generally what happened. It was a well-used machine, wasn't very old, and it only occasionally missed, but it was getting more regular, but only when they were away. So this is the process. You have to ask them the question, you have to get the answers, you have to take what they say, and you have to learn how to filter it. And what they tell you is very important. And then what you have to do is you have to look at the service manual, but it's about 50 pages thick, if not more. Then you have to check again what it is or is not doing. And then you have to work out what it is. And having done that, followed the system, you can replace the part and test. It wasn't the computer boards. It was not around the head drum assembly, it was a belt. Why was it a belt? Because it could be. How was it a belt? Because it was. No, what it was, when the machine was parked up for any length of time, like when he went on holiday for a few days or whatever, it was quite happily sat there, and when the machine fired timer, it would try and operate the loading mechanism and it would not pull the tape in quick enough. Think system, find the fault. It's a very simple way of doing it. It's to stop you going off on tangents. If you think of the system, most of the time it's just simplicity. It's thinking clearly, it's understanding the problem. It's the difference between wanting something to happen, knowing that it should happen, and seeing why it happens or doesn't. And if you follow this little process, you will find that if nothing else, you can make better decisions about what you're going to do, what you're going to spend your money on, and how you're going to do it. So, troubleshooting. How to troubleshoot. As you can see, it takes all sorts to do troubleshooting. Hobbyists have a habit of going off in the wrong direction for the simple reason that they haven't thought about what they're trying to do and how they're trying to do it. They also have a habit of listening to rumours and myths, and that doesn't work very well. Sometimes a stock fault is known, but more often than not, when you're dealing with particularly old equipment, the stock faults have been cured. What you're looking at now is stuff that is specific to that particular unit. Resistors go open circuit, or they go high resistance. They don't often do anything else. Capacitors can go short circuit, open circuit, or they can just sort of go weird. Coils, now they're interesting. They can go short circuit, they can go open circuit, they can overheat. They normally suffer from the results of other failures, and coils are vicious. If you've got coils, they can bite. If you think about it, the high voltage in a CRT is generated in a coil. Solder joints, now, they are the bane of life of all the people in the industry. They go dry. That's what we used to call it. You've got a dry joint. What they actually meant by that was one of many different things. They could have been badly overheated when they were soldered on. They could have melted the pads. They could have had various other things. They could have or they could have gone corroded. It's not unusual to see a leg of a component with corrosion, and the solder, having been beautifully flowed up the leg originally, is now not contacting. At the end of the day, it makes a hell of a mess when these things happen, but you can do what you can do. The thing about coils is they're very often heavy, and if you've got coils and you've got solder joints, there's a good chance that there's going to be problems with them. So always was useful. Some of the TVs we used to do, just an aside, some of the TVs you should bear, they were lovely. Mechanical adjustments. Now this is one of the things that I find really annoying on the groups. By and large, mechanical adjustments do not just move. Certainly not for no reason. Now, the reason may be that vibration or impact, but they just don't decide one day to not line up because they can. They have to have a problem. If the screws are sealed and they're not loose, they are almost certain to not need adjusting. So look somewhere else for the fault that you think is down to the physical adjustment. That includes tape heads, that includes IF coils, that includes anything where there is a screwdriver slot and the, how should I put it, the temptation to give it a twiddle and see if it makes it better. Don't twiddle. It won't make it better, probably. And if it does make it better, you were lucky. Anyway, don't do it, unless you have to. Now this is how you deal with the similarities and the differences between circuits and things. AM radio, transistor radio, standard superheterodyne radio, AM valve radio as we call it, or tubes as the Americans call it. Look very similar but very different. Now there is a system block diagram for what we've got to do, and hey presto, AM radio, there's all the appropriate blocks. And then we go on to the valve radio, and again there's the same blocks doing the same jobs. Two different technologies and doing exactly the same thing. Any engineer could find the problems at least down to that level, and it's not a problem. But what you must remember with these systems is that valve radios and television things tend to have live chassis, which means that they will kill you if you touch them when you shouldn't do. Whereas transistor stuff tends to not be like that, except of course if it's the high voltage stuff like TVs, even they'll get you. So please, 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 do not do this if you don't know what you're doing. I'm not telling you how to do it, I'm just telling you how to think about doing it. Please keep safe. So there we go. Now that's the end of this video. If you'd liked it, then give us a thumbs up, give us a like, give us put any questions you got, put them in the comments. I'll come back to you, no problem. If there's anything else you'd like to see in the way of videos, let me know. So like, subscribe, and thank you very much. Hope you enjoy it. Hope to see you again. I will be doing more videos. I will be doing simple ones because that's the whole idea. Life shouldn't be as complicated as it looks. Just keep it simple.